Hello and welcome to CTN. To learn more about the show, please visit ciotalknetwork.com. And the topic for today is the metabolism of knowledge in agentic AI, governing AI before it governs us. So here, what we are seeing already is it is no longer AI being seen as an assistive intelligence, or it's not just assisting us. It is almost trying to, or it is taking a driver's seat. When you look at our own body, we have got metabolism happening, and there is a way, there is a science, there is a system that our body uses to keep things in balance. But is that truly happening in this world of AI, where there is some data being cracked, some insights being created, some learning is happening, some analysis and relearning is happening, or metabolism is actually kicking in? But is that truly in that balanced state as Mother Nature has given us? And if not, what kind of guardrails, what kind of balancing, what kind of approaches we have to take so that whatever comes out of it, it is truly unbiased, it is really meaningful, and it is not going to take us in a direction where AI, besides controlling us or trying to control us, doesn't cause any other harm. Interesting topic. For that, I have with me Vince Kellen, who is the Chief Information Officer of the University of California, San Diego. Hey, Vince, how are you?
Good, real good. Glad to be here.
Glad to have you again. Now, so Vince, this topic is rather an interesting twist. There is an interesting twist, and we did discuss about it. Why don't we start with you giving a context of what's the genesis of something like this, and really, very, very creative way of looking at human metabolism and trying to draw a parallel to what is happening with AI. Give us some background.
Yeah, the genesis of this started with our own work with our own AI platform, in which we're using open source tools and NVIDIA hardware on premise. And between me and the development team, we're starting to understand the complexity of knowledge and how knowledge flows through an organization, how knowledge flows into a system and out of a system. And with AI, how knowledge that gets represented by the AI to us is actually a collection of little fragments of words, sentences, and phrases from myriad places. And dawned on me that this is a very similar problem to metabolism in the human body, where your body produces molecules, but they're coming from all sorts of other molecules and atoms from elsewhere in your body. And we're coming to the realization that the complexity of what AI is trying to accomplish, which is take all of this body knowledge of the world that it knows of into it, as well as new knowledge, and then represent it back to us in novel forms, is an extremely complicated problem. In fact, I think everybody's underestimating the complexity of it. So everybody keeps talking about AGI and superintelligence, and all these things are going to naturally happen. I'm not certainly convinced that that's a fait accompli at all, because of the complexity of the knowledge out there. So what that means is there are a number of problems that are beginning to surface with AI. Obviously, one bias and control. But we started to think, okay, we need control at many different levels, right? And so the origin of this was the metabolic framework. It's probably not a bad one, because we want to keep the AI working in a certain narrow band of quality or performance or outcome or safety. Exactly what the human body wants to do. So that's the origin of the story, is that we need a more sophisticated metaphor in order to make progress with AI.
Would you say there is a fear of the unknown or paranoia that whatever way these organizations who came up with these different models and the way they are processing, the kind of interfaces are given and the kind of outputs that are coming out, are they not looking at it? Is it something that we are trying to build our own layer of safety, and that's what's triggering this thought process of us looking at metabolism as almost like a safety net or a safety check on top of what these top level companies who are putting a lot of money into it are not doing?
Yes and no. It's a realization that the GPT, the general program transformer model, pre-trained transformer model, that model is locked, fixed. It's sort of monolithic, even though there's some modularity in it. It's a kind of a monolithic model. So it's like a big lawnmower that's gone over all of the information of the world. That in and of itself has insufficient capability to provide all the regulation we need. So when I say regulation of the AI within a homeostatic band of performance, there's different levels of this. So at the top level, we have societal, industry norms or organizational norms. These are just norms that we would like the AI to perform in, where a lot of the debate is right now on the regulation of AI. We have a second level on federal and state law, typically privacy and data and those matters, and we've seen law come out that's looking at the safety of AI. When you get inside the organization has its own policies, procedures, and processes that the AI will need to respect and work within. And then, of course, within the technology itself, you have both the inputs and the outputs, which can be evaluated for safety, quality, et cetera. And then inside the AI, especially the agentic framework, we have a lot of components now growing quickly, especially agents, typically Python code running in the environment. Each one of those needs a little bit of a checking as they're running in order to stay within a bound of safety, and start to design that into the tools. And on top of this sort of 5-layer cake of regulation, we now have a really big form of a type of regulation. The regulation you've been applying so far has been crisp logic, first order logic. If this happens, that you have to do this, or if we see this, this has to happen. That's been our world in law and regulation, policies, procedures, et cetera. With the LLM now and AI, the LLM itself can be a participant in its own self-regulation, but it will be a probabilistic approach. It will never be 100%. In a way, that kind of mirrors metabolism. Metabolism isn't a completely perfect regulation system. So type 2 diabetes and metabolic syndrome are a perfect example of it. There's no regulation on the upside of calorie consumption and food consumption. So the probabilistic approaches and metabolism begin to break down in that particular disease. And same thing here. So we're now having to contend with this new animal of probabilistic judging, so to speak, of how the AI is performing. Interesting, complex, a lot of tools to address these levels of regulation, but there's also a lot more complexity.
Now, I have a two-part question. Number one, if we had to tackle at the human metabolic or whatever that you are referring to as a parallel that you're drawing, that human metabolism, and if this was to be tackled, would it be better tackled with a central set of bodies who bring this together, or you're better off federating it and saying, okay, this is your body, so you take care of it. So if UCSD, which is your organization, is trying to do something with these LLMs, then you're better off given control to tackle your own metabolic approaches to AI inputs and outputs versus getting motherships. If not one, multiple motherships who work together to give you much better outcome, because at the end of the day, that guardrail that you're creating is also a lot more sophisticated, which will require resources and time and energy. And would we really be equipped at individual human level or individual entity level who's trying to do this, the kind of activity that you're talking about, metabolic control? Would we be so equipped to do it individually, or you're better off pushing it upwards and more evangelize it? So you can powers take care of it.
I sort of flip the question a little bit. Can human sociology accept one master AI to rule them all? No. And I'll give you an example. China released DeepSeek, Perplexity put it into their platform. And the first thing they did is they kicked off the guardrails that DeepSeek had on to respect the Chinese national societal norms they wish to impose on the AI. So there's a case of once the open model is released, an entity to Perplexity comes and says, okay, this is a cool model, but let's shake off some of these regulatory frameworks around it because it's not what we agree with. So I think disagreement between humans around the regulation, especially around societal norms, is going to be an interesting one. So I don't think there will be any form of a single mothership that will drive that. Maybe at a national level that can happen with national law. And even if in the presence of a national law, there's the tailoring of it to hit the norms and the policy procedures and rules within an organization. So organizations will have differences in how they operate. And that's my point. AI is going to be a derivative of the complexity of human sociology. So therefore, the regulatory frameworks around it will also have to be as complicated as the human sociology. So no, it'll be impossible to have sort of one mothership directing all of this. And I think a good part of the world is very much afraid of that.
Now, on that, the second part of my question, thanks so much for the response to the first one. The second part is that if we try to become too customized for each entity, and of course, hopefully not each human being, but each entity, when we are talking about metabolism of AI, then each organization might in its own way think, okay, I have created the right guardrails, but then that would create way too many flavors and there would not be any adherence to any standard. So if any new evolution that happens, because even the AI and agentic AI is evolving, then we will always keep playing catch up and some people will unknowingly be not in breach, but in conflict with the very intent that they started with. The guardrails will keep breaking because it's a moving target.
True, it's a moving target, but each organization competes. Each company competes with its other competitors, and it competes based on its knowledge, how it wishes to render its knowledge. It competes with how it issues its policies and procedures internally, its business processes. So AI will be suitably tailored to meet the competitive and strategic advantage of organizations, whatever that may be. And if it is truly strategic, which I believe it will be, then there will be heavy tailoring to match the organization and compete upon it. I think that's a central fight now between the AI providers. Is there enough distinction in inference alone for them to compete? So I think, that will always be a risk, but we have that risk today in our own policies and procedures independent of AI, moving targets, especially anything related to technology. Good. I'm not seeing a ton of variability or distinguishing qualities of AI. There's a few big ones, no question. By and large, the current regulatory framework is not necessarily ill-equipped to handle it. We just got to learn how to use current regulatory framework, especially law and national policies to do that.
So now that we have spoken like a skeptic, what should happen and whether it is really a good way for an enterprise to start, what's your approach to even tackling something like this where you're coming in, not truly blind about what's going on internally, but to quite an extent, most of the models that have been created, overall, as they become more complex, if the outputs become more complex, the internal working becomes more opaque to us. So are we trying to eat the cake and have it too, which means we want explainability, but at the same time, we also want the guardrails and we also want the bias checks and everything else? Is that realistically possible? And is that what you're trying to tackle and trying to accomplish?
I think it's very realistically possible. I think we're seeing evidence of it in the cost of, understand inference is a locked model. It takes a long time to build a model per se. And then block, it doesn't change. And so all the complexity now around this is going to be in the agents being developed and marketed. And there's a gazillion of them right now occurring, and we're building our own agents. The barriers to entry for building those agents have dropped. So this is kind of like how HTML lowered the barriers to entry for application development on the internet at large. So anybody could create HTML, anybody can create websites and do e-commerce real quickly. We're seeing the same thing here in AI. As those barriers to entry drop, you get a lot of agents being built. And so think of the big focus of the regulation now is going to be in those agents. Now, the good news for organizations is if you buy agents from a vendor, you can look at the contract and you can see if they will reveal as much of the innards for you to understand how that company is controlling those agents and whether they got the right controls around it. In our own work, since we develop a lot of our own agents, it's what's the software coding technique? What's the technique between the agents and the tools underneath them that retrieve data from other systems? How do they work? So the good news is it starts with kind of mundane, old school regulation. Is this particular agent performing per the output we want? Well, how do we do that? We bring our users in to help evaluate and judge the output, which now looks like conventional testing, software testing. We get our users to rate thumbs up and thumbs down on the content, as well as qualitative feedback. All of that becomes knowledge that's fed back into the AI that helps to improve its performance. That's unlike software development, where you release just good old-fashioned software. Users say, wait a minute, this isn't right. They give you feedback. The next version of it comes out, tries to correct it. So I think the good news is the bulk of our work is going to be in that form of regulation in the agentic world. For the LLM, we could talk a little bit about how we can look at how the LLM itself is producing output. And we've got some approaches we're using there. So it's particularly worried. And yes, I think organizations can easily do this, especially since the barriers to entry have dropped and the number of models has increased dramatically. The cost of tokens for the inference have dropped dramatically. It's becoming commoditized almost soon to be. In fact, it's being offered by some organizations, some of the providers to organizations as free. So in that environment, it's going to look a lot like Internet 1 revolution.
So Vince, you've been CIO for many decades, right? And before this AI,
just a couple. So don't do panic attack here.
So the reason I'm saying this is because, see, when the IT portfolio was being built, right, and the focus was not to do tech for the sake of tech, and you are the most pragmatic leader. I'm one of the most pragmatic leaders I've seen when it comes to managing IT. I know you always evangelize the concept of, build, buy, rent, lease, whatever is needed, and so that the perfection doesn't get in the way of good. Because you, at the end of the day, are doing this for business outcome versus a cool geek project, right?
Yes.
So, and then now you at the stage where we are with respect to AI adoption, we are seeing some vendors. And when in IT, when it was cloud vendors or anyone else or any other SaaS vendors, we always spoke about we are not able to see under the hood, and that's what created the skepticism. But we still went ahead with it, at least as part of the portfolio, because we wanted to get the work done. So what has been your approach as you're dabbling into it? Would you allow good to prevail, or would you seek perfection because you feel the risk is way too much for you to allow good, which is not the perfect? You can't see under the hood for everything. And yes, your guardrails may be there, but they may not be perfect.
Our real world experience has been that good is good enough to make progress. You don't need a highly sophisticated model or set of toolkits to make really good progress. The large language model works out really well on mundane questions, and most people have mundane questions or more mundane tasks, where the big providers have been focusing on things like reasoning and deep research and what I call predicate logic type reasoning within the LLM. And those are going to be useful and helpful, but 85 to 90% of what goes on in an organization tends to be a little bit more mundane. So we focused on speed that up, make that go faster. And you can control the temperature of these LLMs, you control their hallucination rate, and you can certainly evaluate their safety on a regular basis and say, hey, that looks like the LLM's producing an adverse response here. So no, there's absolutely enough open models, pay models, and closed models out there that you can make progress. Our own TritonGPT platform largely uses Llama models, but we also go out to models for a couple of tasks. So we're going to keep this flexible approach to choose models for certain cases. People say, oh, that's complicated. Well, I don't have a large team doing this, and I have actually some students working on it. This isn't requiring rocket scientists to do the work. I think that's what people don't understand is that I look at this as the 21st century application development environment for IT shops. It will overwhelm all other forms of application development over time here. People will be coming in using AI to write code, using code to put into an AI system. And there's enough to make great progress right now. We're already seeing it in the market. So I think there's enough practicality here to make progress. But our approach is keep it flexible, keep it low cost, democratize it, and be ready to shift as the market shifts.
Now, based on what you've tried so far, right? And I'm sure you've done some sandboxing. Maybe you would have tried to put that in a limited, controlled environment in a live setting. What has been experienced so far with this whole metabolism approach to balancing what AI produces so far in your lab or in your setting?
Well, in our setting, we actually have a number of assistants we've created, and some of them are mundane, like our job description helper. We got a UC San Diego assistant, which is tapped into all of our UC San Diego content, and it can give answers to questions like, hey, where's good dining on campus, to what are our policies around expense reimbursements overseas. We have a contract reviewer one, which the legal teams or the teams looking at non-disclosure agreements and soon other agreements, they just email it to an email box. It gets picked up by the platform, and then it gets redlined with our templated language and shoots them back a copy of the document, saving them a whole bunch of time on initial document review and redlining and highlighting. We also have a data agent fact retrieval assistant in which it can fetch accounting data for you. How much money do I have left in my budget? How much money do I have left in my grant? Thus bypassing the BI layer. So we've got a number of practical things that are out there. Where the metabolism comes in is under the hood in our neck of the woods. It caused us to think about how we develop these applications in a more sophisticated way. And I'll give you an example. I was talking to the teams and saying, hey, as you're writing the Python code to create an agent, that's a form of knowledge. Your knowledge could be used in the AI to help automate how you create those modules. So think of it as AI creating AI. Now you're thinking Skynet and all that other stuff, still under tight human regulation, but saving the developer time. Or here's another example. When users interact with an AI platform, they themselves are asking questions. The AI platform is giving answers, in some cases recommending questions, but we actually give our users some recommended questions they can ask. That improves the quality of their questions. It also brings an answer that gets rated up or down. All of that knowledge is knowledge inside the organization that now is inside the AI that can help improve the quality of the AI, even though the transformer model is fixed and not changing. So those are examples where we're thinking about everything as a knowledge fragment, whatever it is, wherever it is, and all of that can be put into the soup of this AI. And then the AI, as it creates new inputs from users and outputs from the LLM, that forms knowledge fragments. All of those can go into this soup and be available for larger knowledge bundles or knowledge molecules, we'll call them, text output coming out. So the metabolism framework really here is just to help us guide our thinking on internal development. It also leads to a really interesting thing in which, as you do agentic development, you can now think of the LLM as not just a generator of text, but a judge on the quality or the appropriateness of the text. The LLM as judge. So in this regard, the LLM behaves kind of like the kidney in the human body. It throws everything around and then selectively includes things that the body needs. So it's very exquisite, filtering or judging. And so that causes us to rethink how we internally, as our development teams, think about the LLM and the agent in our process.
So let me take an example of a sausage factory, right? Basically, I'm just going to use this to make a point. If you got sausage factory and you have to make sure that there are no germs and there is a certain approach to how it should be produced as a quality, and there is a definition of quality, and as the thing flows through it, you look at every level, but you also look at the input and the output to make sure that the whole process is producing what is supposed to be produced, and if there is any anomaly in any new type of input that you gave, or there was a variation, then it is caught in between, or if there is the system within doesn't have, or the guardrails that you put in there, the quality checks that you put in the system itself, if it is not working, it triggers it. So somebody has to watch it, or the system itself has to trigger. Now, that was a sausage factory, which has still got a limited number of inputs coming in, and it's far more practical. But now we're talking about that taken to a total level, different level, because the type of inputs would change. And now AI is creating its own AI, like you said about the agentic AI could be working. So who is watching?
In our case, we are. What we call an ensemble of experts approach to safety. What that means is we have a background process that runs every day and evaluates the inputs and outputs to the system. And it looks at it from a variety of aspects for safety. And those aspects include things like, are there information hazards in here? Are there malicious uses? Is it being exclusive? Does it have some level of toxicity to it? Looking for offensive statements, misinformation, harmful interactions between people, criminal planning techniques, regulated or controlled substances, which might be problematic, self-harm, illegal weapons. These are all rubrics and frameworks that the research community has been using to evaluate safety of LLMs. We've taken those, we built it into this. We use five other models to evaluate the safety of those inputs and outputs. So we are using different models under the concept that we can't trust any one model to evaluate what our AI produces. So we use 5 or 6 of them. It's always automated, and then things are flagged, and then the teams run down what's flagged and look in deeper to see if there's an issue. That's one form of what we call out-of-band safety checking. I think we're going to, many models, especially Llama, already have in-band some safety checking in it. But I can see down the road, we're going to get more interesting forms of in-band, meaning in the middle of the interaction, additional safety checking going on. So you're right. You have to mind the store, no question, on this. If you got a probabilistic engine that's getting more sophisticated, you got to make sure your homeostasis processes are as exquisite as the information going in and out is.
So if I were to compare to something like an accounting, right, where you got the checks and balances built into the very accounting system, which has got the guardrails, but then on top of it, you do internal audit, and then on top of it, you do external audit.
So 2 sets of eyes on each transaction.
Exactly. So if you were to look at AI, what you just said that you're going to watch it, is that the system already that you put in place, you are claiming that you put in the checks and balances, and you guys are the internal auditors. And then on top of it, you're going to bring external pair of eyes to see whether whatever the checks and balances are and what your internal audit is it truly bringing the output which you thought it is supposed to bring?
Yes, and we are absolutely doing those checking today, and we're absolutely able to deal with external auditors who want to come in at logs and all this stuff and evaluate. And I think external auditors and internal auditors are going to get better at this as the years come by. In fact, if I were an enterprising auditor, I'd want to really specialize in AI system auditing. So it'd be very interesting, especially when AI can control very critical processes in certain industries. That's going to be an interesting point.
So governance is traditionally seen as an overhead, in most cases, because, and I'm not saying it's not a necessary evil, it is, and everybody should pursue, but still is seen it. And a lot of times when you have to make a case for it, whether internally in an organization or as you're evangelizing this for the rest of the world to adopt, there has to be an ROI discussion on this. So what would all this bias and what all has this bought you besides a good sleep at night?
The governance, there's many levels of governance. And I remind folks that when the homeostasis of the technical system is in an extremely narrow band of output and an extremely high quality band of output, you tend not to have governance. So we don't have governance over the plain old telephone system. That governance has disappeared long ago, if there ever was. So as technology matures and it becomes extremely reliable, the governance needs begin to drop off. So we're in this early state of AI that's going to occur over the next couple of decades. So governance will be necessary. We'll need to be evaluating that. And again, you take this multi-level approach to governance. There's organizational governance. Are we doing the right things? Are we prioritizing the right work? Is the work that's going on of suitable quality and safety? And that is necessary. You need to do that. And then when you get into the technical construction environment on how to technically build these things, you need all your normal software engineering checking that goes on. You call it governance. It kind of is. And so you need all those pieces. So yes, we need the governance. And it's not necessarily heavy governance. Doesn't have to be heavy. Most people are, and rightfully so, very concerned about the new technology. So new technology is always held to a higher level of scrutiny than the old. This exact same thing happened when the internet hit. Everybody was looking skeptically at the internet and thinking about, okay, what governance should we put in place? And then immediately higher barriers or higher quality levels, creating barriers to entry for organizations to adopt the technology. In the marketing world, when the internet hit, everybody was concerned about, well, can you really measure this on the internet? Is it really effective? In the early days of the internet, people were looking very skeptically at whether the internet would really be successful in marketing. There are a lot of barriers that companies put up to adoption. Some of those companies put up those barriers are no longer here, and you're seeing that the internet world has taken over marketing from the rest of the world. So we're getting a similar thing here with AI. A lot of what I call organizational aversion to adoption early, but in time it will grow as the technology matures in its quality.
So AI governance is not new, right? From the very get-go, people were concerned, so they started putting things in place, and a lot of effort has been put in. So if you were to bring this human metabolism parallel to the AI governance in your model, how is that playbook being tweaked, and what is your recommendation for any organization which is already doing AI governance? What would they do any differently than what they're doing now?
Yeah, my recommendation would be that the first place we go is governance of, the priorities and the safety and quality of the overall system from a very human standpoint. We need to shift quickly into how are we regulating the actual software construction, and how are we ensuring that the agentic framework doesn't go off the rails on us? And that might be largely a CIO concern. It's the same thing about how do we make sure the software engineers aren't having this go off the rails. My concern is the barrier to entry gets lower, meaning by both vendors and us to develop agents. I did get quite a bit concerned about the quality of those things. The good news is in the market, if a company buys agentic framework X from small company Y, and within the first 6 months of piloting, it's suddenly not working, they're going to reject it, and word gets out that this product is having trouble. So there'll be some self-regulation sorts in the market. But we need to think kind of at lower levels of concern, and certainly in the CIO world on this. So CIOs have to get deeper into the stack and make sure they understand the componentry under the hood. It's not unlike if you're going to buy a car and there's pieces manufactured from other parts of the globe. Somebody's got to understand where those pieces are coming from and if they're of suitable quality as they go into the car. The other piece to this is our deployment methodology is shifting to what I call operations, and is a continuous delivery sort of way in which, especially with new modules or new applications that you develop, you deploy to a very limited audience, and you just slowly you incrementally increase the size of that audience as you do this thorough feedback with the community around quality until everybody gets comfortable that this is operating within bounds. But then you're also prepared to reverse that spiral and reduce the audience in size. So it's a much more dynamic, real-time testing and feedback approach versus, develop for 3 months or go a sprint for a month, then test for 2 weeks and then release. This is a little bit more, not quite daily, but it's a much more fluid environment that we have to operate in. So I think the development methodology has to rise to the sophistication of the technology as well.
So if you had to, since you have been evangelizing this concept and you want to appeal to the leaders within an enterprise to go ahead and take a look at it, and what's the risk of them not doing it?
Well, the risk of not doing it is if you apply the AI to a very critical process and you misapply it and you under-regulate it, you open up yourself up to legal risk. It's no question. And so you've got to choose your targets that you're going to release to carefully. And this is part of an article that came out about the jagged frontier of AI, which is still true. It's not quite clear for many organizations, will this process or will this application work in AI? And so you got to kind of make sure you carefully do that. And then at the same time, you got to get with the IT teams and the manufacturers of this and start to dig into their componentry and ensure you've got the levels of quality in there and transparency in it to the best that those vendors will want to do that. Yes, I think I don't necessarily evangelize metabolism to well, actually, I just was speaking to some accounting folks about metabolism and saying, hey, your world is going to get more complicated here. I mean, you need to think about how you're doing your accounting work in these more complicated ways. But the practicality of this is we're all going to have to get more sophisticated in how we think about the control over the new technology because its degrees of freedom are far, far wider. The phone system has very few degrees of freedom. It's really electrons moving down a copper wire. And it's just a voice signal on top of that. There's a tremendous variability that you can do with that. Here with AI, there's a tremendous variability of the output that it can generate for us.
Is this truly a tech project or is this a change management involved as well?
I think it's both. It's a change management. In fact, I think it's largely now a change management problem. I think the technology is quickly sorting itself out with this class of GPT technology. We get a replacement to the GPT, which I think there are some interesting concepts here on that would create a new wrinkle. And now it's a lot of change management. And instead of using the word change management, I'm going to call it adoption management. Because you're not trying to, yes, you're always trying to get people to change, but you're trying to get people to become comfortable with it and grow in their use of it. Part of the way we're approaching AI is there's two ways to encourage that adoption. One way is to help with a bespoke assistant like our JavaScript helper, our fund manager approach, and our legal contract reviewer, where to the user it's kind of a black box and it's easy for them to interact with it. That's one use of it. But many people have many different knowledge tests that they do on a daily basis that might be idiosyncratic to them, special to them, that could be aided tremendously with the generative AI. And so that's going to require deepening adoption by the individual person. And it's also this, how do we encourage the adoption in a way that works wisely, correctly, and actually benefits the person and the organization at the same time? So I'm calling it change management, we're calling it adoption management.
If you had to appeal to the leaders within respective organizations that they go and take a second look at what you're proposing, right? Draw a parallel between human metabolism and try to bring that in. What would you want them to start doing and thinking and saying differently for this to gain ground and actually get them the outcomes that they need to get?
Yeah, and it depends on the audience. If I were talking to a CEO of a $6 billion organization, I'd ask the CEO, do you know how many IT systems you have? It might be like 200 or 300. Okay, each of those has data. Do you know how many web pages, PDF documents, and other loose content you have in your organization? They might come with an answer that says, we got 30 million of them. Okay, great. How much of this knowledge is peculiar to your organization? So, well, there's a lot of that knowledge that's peculiar to our organization we want to protect and improve. So great. You now have, through AI, a tool that can ingest the sum total of all that and produce really interesting output for you and control potentially over processes. You're going to think, well, that's too much for me to think about. Absolutely. You're going to need a regulatory framework and a construction framework or a purchasing framework that matches the level of sophistication in your current IT technology. So you just don't simply go to an AI provider and say, here, find me AI. You want to knit this into your organization. So it's really using your knowledge in a way that is enhancing your competitive advantage. What does it mean? You think deeply about that knowledge. You have to think deeply about the people in your company who are creating that knowledge and how they do it and how you wish to enhance and curate that over time. So now you're going to have people who are just simply typing transactions into a system, but their mind will be interacting with the system and enhancing their mind while also enhancing the system. So now you have a technical human system that is getting really intimately connected. You need to have good regulation around that to make sure you're not missing targets, overshooting targets, or going off the rails.
Once again, thank you so much, Vince. This is a rather fascinating conversation we had today, driving a parallel between human metabolism and how metabolism of knowledge happens in agentic AI or should happen in AI, and what kind of guardrails we should put. So thanks so much.
Thank you. It's been a pleasure as always.
Thanks so much again, Vince. And listeners, please connect with us on social media, subscribe to our YouTube and podcast channels. Once again, this is Sanjog Gaul, your host, signing off. Till next week, take care and God bless.